Alrighty, so today I have a Halloween themed edition of Chaos Engineering. Seems very relevant. So yeah, the road to resilience. Today we're going to talk about chaos engineering, disaster recovery, and game days. I'm a principal SRE at Gremlin, and if you're wondering what my accent is, I'm Australian. So often folks like to guess that one. And definitely feel free to add me on LinkedIn. You can just see my URL there, linkedin.com/in/Tammy Butow. And I do share a lot of like cool things related to chaos engineering, site reliability engineering on LinkedIn to just make it easy to get really interesting updates on what's happening in our world. So feel free to connect there. Just yesterday, we launched a new certificate program for chaos engineering. It's actually a second level, so professional. And that is over on LinkedIn. You can see all the folks who are now getting their certificate, which is exciting. And I'm also on Twitter at Tammy Bryant Butow. Prior to working at Gremlin, I worked at Dropbox as a site reliability engineering manager, leading databases, block storage, as well as the build systems, developer tools. I did that for several years and got a lot of great wins, like a 10x reduction in incidents just within my first 3 months by practicing a lot of proactive reliability engineering, like chaos engineering. That's one of the examples, disaster recovery testing, and doing mini game days, which I'll talk much more about today. Prior to that, I was at DigitalOcean, helping create a cloud infrastructure platform for developers all over the world. And then I spent 6 years at the National Australia Bank, also doing SRE work for mortgage broking, internet banking, foreign exchange trading. So lots of really interesting different types of environments. It's been really cool to work at Gremlin the last 4 years, where I get to work with a lot of different customers from different industries, and they often share how they're practicing chaos engineering with Gremlin. So e-commerce, we have Target is a customer, Walmart, a lot of banks as well, like Chase. The National Australia Bank, where I used to work as well. So just really interesting to see the similarities and differences based on each of the industries that you'll look at when folks are looking to practice chaos engineering. So if you have questions, feel free to ask them at the end. I'm totally happy to answer any questions about SRE, chaos engineering, how to actually practice it, Gremlin, whatever you would like to know about. So one cool thing that you can do is you can get certified in chaos engineering for free. So what I'm going to cover today in this talk will actually prepare you to be able to get certified. This certificate takes around 30 minutes. I think the fastest anyone's achieved it was in 12 minutes. It's mostly multiple choice. Definitely recommend checking that out because it's a really great certificate to have. A lot of our customers too, they said, if folks got certified in this, we'd really think that, that's someone we would want to talk to and meet and network with because they're also interested in chaos engineering, and getting this certificate shows that you have the motivation and the determination to learn new skills and acquire them. And the other great thing is you can add it to your LinkedIn profile. So something that you can keep forever. It doesn't expire. This is really like a foundation level certificate for chaos engineering. What is it? How do you practice it? It's been the same way for over 10 years and it continues to advance, but this is a good foundation level explanation. So give it a go. So I'm sure you've probably noticed actually over the last few years, there's been a massive increase in outages or, high severity incidents, what I like to call them as well. This is a news headline from Amazon. They had a big outage in Japan. One of their data centers went down there. And it was actually a 6-hour outage that disrupted just a huge number of businesses in Tokyo. So this impacted online brokerages, a leading mobile phone carrier, the country's biggest airline, just so many different, different critical businesses were not able to function. So for example, just specifically, flights were delayed after problems with ticketing and check-in systems. Just one small example, but for 6 hours. That then has a domino effect. I'm sure you all know that. When one thing happens, it can actually result in a large number of issues occurring way beyond that 6-hour outage. So there's just a lot of problems that occur. And what I love to do is try and figure out how can we prevent this from ever happening again? Once something has happened like this, how do we make sure it doesn't happen again? Because there's that feeling too, right? As an SRE, wow, something that happened. All right, like let's figure out how we can make sure it doesn't happen again next week. Like we would be maybe embarrassed if it happened again, exact same thing next week. So we're trying to scramble to figure out how we can prevent this from occurring again. And chaos engineering is a really good way to think through that in a systematic way, in a logical way, and also as a team. So you don't have to just do it by yourself. You can do it in a way that actually includes all of your coworkers. That's why I really like it too. It's a great way to learn from each other. Another thing that I recommend checking out if you're interested in this whole area of chaos engineering and game days is the book Accelerate. So if anyone's read this book, like give me a yes in the chat. It's a really great book. Definitely recommend you check it out. It's by Gene Kim, Nicole Forsgren, Jez Humble, and they have done an amazing job collecting all of the research that they got from practicing DevOps over many years, but then also actually doing the DevOps survey, the report that Puppet would send out. I'm sure many of you have seen that come out. Probably you've responded to that DevOps yearly survey as well that Puppet would send out. So they took 4 years of research, and Nicole has a PhD. She also created the Dora report, Dora metrics. Jez Humble is an SRE at Google. Gene Kim wrote the Phoenix project. They came together and analyzed that data in a really great way to be able to bubble it up, to pop the stack and say, what are the most important things that you need to do to create a high-performing technology organization? So building and scaling those teams. So let's dig into that, because I read this again recently, and it's just like really, really spot on, I think, from what I've seen over the last few years. It's what we need to be doing. So today I want to explore with you 3 key practices that improve tempo and stability. So in Accelerate, they focus a lot on those 2 measurements. A lot of the time people say, how do you measure chaos engineering? How do you make sure that you're doing the right thing when you're doing this work? How do you prove that the work that you did actually makes a difference and is able to move the needle, especially if you've got a number of different people doing different projects? It's really important to be able to measure back and say, this was the work we did, this is how it moved the needle, and this is the results or the ROI that we got from doing that work. So tempo and stability. Tempo is measured by deployment frequency and change lead time. Stability is measured by mean time to recover, MTTR, and change failure rate. So if we break that down a little bit further, deployment frequency would be the rate that software is deployed to production or an app store. So for example, within a range of multiple times a day to maybe really long deployment frequency, like once a year. Tempo would be change lead time. So the time that it takes to go from a customer making a request. So say a customer has a product feature request to that feature actually being built and rolled out so that the customer can use it. So from the request to the request being satisfied. Then stability is our mean time to recover. So the mean time that it takes a company to recover from downtime of their software, and stability change failure rate. So the likelihood of defect changes. If you roll out 5 changes, how many of those will have a defect? How many of those might you need to roll back, or might you need to apply a patch for because there was an issue? Is it 1 out of 5? Is it 2 out of 5? So those are the types of metrics that Accelerate recommends measuring. I really like these 4 metrics. I think they're great. So these 3 key practices are chaos engineering, game days, and disaster recovery. And the really interesting thing with Accelerate as well is that it says that you should focus on improving reliability because it is the foundation that enables you to have a really great tempo. So it enables you to improve developer velocity, which makes so much sense, right? But it's just nice because they're backing this up with data over 4 years of research. I've always thought this because as an SRE, I believe that engineers feel more confident when software is reliable. They feel more confident to write new code. They feel more confident that their features that they're building are going to work well. They understand all the different failure modes because they've been focusing on reliability. They've been trying to improve reliability. So that makes you be able to actually ship code faster. And also, over the years, I did work as a feature developer. I worked as a full stack developer. So I was responsible for reliability, but also pushing out new features within a number of different teams, like, for example, mortgage broking. And I always wanted to fix the reliability of the mortgage broking platform, which I did with my team, so that we would be able to ship new features out and feel like they would work and we could trust them and they would meet regulation, meet compliance requirements, all of those important things. So let's dive into that more. Chaos engineering, game days, and disaster recovery, 3 key practices. So in Accelerate, it says that we should build systems that are designed to be deployed easily, can detect and tolerate failures, and can have various components of the system updated independently. So this are a lot of different things that are really great to aspire to and work towards. Let's focus on detect and tolerate failures specifically. So what is the best way to know if your system can detect and tolerate failures? If anyone wants to guess in the chat, go ahead. So what would that be? How do you know if your system can detect and tolerate failures? Chaos engineering. So that's the answer. The best way to be able to know if your system can detect failures, can tolerate failures, is to purposely inject failures, real failure, and see how your system handles that. So now I'd like to show you a real demo. I always think it's great to be able to see, what does this look like? Like, it's great to understand it and understand the practice and the theory behind it, but let's look at an actual demo related to dependencies. So this is actually a really cool open source project that you can find on the Google Cloud Platform GitHub webpage there. So it's a repo called Bank of Anthos. Definitely recommend checking this out. This is the architecture diagram. It's really great for learning how to practice chaos engineering because it is a banking application. It looks similar to an internet banking application. It has multiple languages, so both Python and Java, which is pretty common these days. Like when you're working on a system, often there would be several languages. There's then 2 databases, an accounts database and a ledger database, which are running on Postgres. And then we have our transaction history service, a balance reader service, ledger writer, contacts, user service, our front end, and a load generator. So this is what it looks like right now. So one of the questions we would ask ourselves when we're starting to practice chaos engineering is, what is our hypothesis? So we want to think through what's going to happen. Does black holing a critical path service like the balance reader result in graceful degradation of the customer experience? So what do you think? Share in the chat. If we make the balance reader unavailable, so we make it unreachable, that's what black holing is. It's actually a Gremlin specific attack. It's called a black hole. If we make that unavailable, what will occur to the application? So anyone want to guess in the chat, feel free to just guess. What do you think will happen? Will we be able to use the website? Will we see what the balance is? Will we be able to deposit funds, send payments? Like, these are all the questions we'd ask ourselves. So, my guess would be that if we black hole the balance reader service, I think that probably we might see an error message, unable to read balance, that we might get a user-friendly error message. We'd also hope that there would be alerting that there was some type of issue with the balance reader service, that it was no longer available. Or maybe it was like really well built that actually we could just fail over automatically. So if that one balance reader service isn't available because it's running on Kubernetes, maybe there's going to be some redundancy there, and we'll be able to actually fail over. So let's see what we do. So within Gremlin, you can select the balance reader service. So we're selecting it as a Kubernetes replica set. We can already learn a lot here. We see within the UI that in the visualization on the right, it says only one pod is impacted. So if there was multiple pods with the balance reader service, then we would actually see 2 pods impacted. So that shows us already, well, when we run this attack, this chaos engineering experiment, we're going to make all of the balance reader service unavailable because there is no other secondary pod. And this is what it looks like. So the balance will appear as dash, dash, dash. So this could be very confusing for a user. I know if I was building this as a real internet banking application for a bank, they would be like, no, Tammy, you cannot build it like this. We're going to get so many support tickets if this ever happens. Like, that's not even an error message. Why does it just say dash, dash, dash? So this could make the user really confused, and they might start calling the call center. That then increases the cost of having to answer all of those calls. So that could be a lot of problems. But we also want to check other functionality. How does this impact other dependencies? So the user is still able to make a deposit of $1,000 while the balance reader service is in a black hole. So you can see down the bottom, our transaction history. You can see there it says we added $1,000 into our bank account. So deposit is successful, got a nice message, but it never updated the balance. So the balance is still dash, dash, dash. But if we try and make a payment, we're unable to do this. And we get, an engineer-friendly error message, but not really a general user customer error message. It's a payment failed, IO error on get request. I think most of my friends that don't work in tech will have no idea what this means, but they will get that message and they probably won't know what to do. So if we look at that a little bit closer, this is something that's really good to think through as well. Personally, like when I was always, working for pretty much like up until I was about a year into working at Dropbox, I never really did much work on the UI of the applications I was building. I was usually working on the back end, within Terminal. I was like used to looking at a black and green screen, and I didn't really think through the whole experience of reliability. How does the user see this issue? Like, how do we represent problems to them? Do they notice that there's a problem? Is there a way to hide a problem from the user and like gracefully degrade? So maybe like just remove a component of the web page if possible, if it's not working at that moment. There's a lot of things you can do to allow for graceful degradation that makes a better user experience. And the reason I started to do this was Amazon actually had a huge outage. S3 went down. It was down for 5 hours. We were getting all these tickets at Dropbox. All of my data's been deleted. Like, this is really bad. Where are all my files? The data was not deleted at all. It was all there. But the thing that had happened was a thumbnail preview service was unavailable, and it had been impacted during that Amazon outage. So all of the users were getting X's when you would log in. And so the only way that we discovered that, because our logs, our alerts, everything's saying, no, all the data's here, everything's good, no issues at all. But when we logged into Dropbox.com, we could see, oh, it's the thumbnail preview service that's not working. Once you click into it, you can actually get your file. But if you don't click into it, you'll just have an error. So that makes folks really worried. So, everything has its wonders, even darkness and silence. I really love that quote when you think about what happens if just a service is unreachable, even for a minute, for 2 minutes. Like, how does that impact the user experience, really? And if you're interested in learning more, I definitely recommend checking out this free demo environment. It's totally free to spin up on Google Cloud Shell, which I think is great. You can just actually click that URL there. I'll share these with Jim and he can send it out to you. I guess there'll also be a video on YouTube, and I can link to my slides on that video. And then all you do is you click Minikube Start. Then in Cloud Shell, you just run this kubectl command to apply the YAML file. Then you click Cloud Code, run on Kubernetes, change the port, and you're good to go. Then you can actually start using Gremlin, and you can use Gremlin for free. There's a free version of Gremlin, so definitely check that out, and you'll be able to get up and running and do exactly what I just did. So another interesting thing to look at is different types of failure modes. So now let's have a look at the transaction history service. Let's see how a black hole might impact that. So this is our transaction history here. You can see here, this is what it looks like when things are good. We have our credits and our debits. You can see who made it, what the label is, the amount. And we want to know, are we going to get a graceful experience, a graceful degradation of this when it's unavailable or not? So there we go. This is what we see. Transaction history, error, could not load transactions. But the deposit is successful. So we are able to make a deposit, but we just won't ever see that it's been updated. So this looks a little bit better though than just the dash, dash, dash. It actually says error, could not load transactions. It's not just a more of a technical or engineering friendly error message. So it's a little bit better there. But how can we mitigate against a black hole? That's the next question. So if you're interested in Kubernetes and learning much more about it, This is definitely for you. So we can run this command, kubectl scale deployment transaction history, and give it 2 replicas instead of just 1. So you saw before when we were looking at balance reader, for example, it only had 1 pod. But now what we're going to do is we're going to make it that there's actually 2. So that's going to be cool. We'll scale replicas. So we'll do this for the transaction history one for this example. Run the command, and now we can say, let's look in terminal and see kubectl get pods. And yes, we have 2 pods that are now running for transaction history to be able to show us that data. So now what we can do is a smaller blast radius chaos engineering experiment. So let's send 50% of the transaction history pods into a black hole. So just one of the 2. You can see down there on the right-hand side at the bottom, it says 50%, 1 of 2 pods impacted. I've selected the transaction history replica set. You can see that it has 2 pods. There's 2 little green pods in the visualization. So, what's our hypothesis now? Anyone want to guess in the chat? If we only send 1 of the 2 transaction history pods into a black hole, will we get the same error message? Will things be okay? Will things be worse? The interesting thing with this is you never know until you actually run the experiment. You're never going to be able to really guess exactly. I think it's very hard to do. So now let's look at the architecture diagram just to be able to really visualize this and understand what's happening. So we have our 2 pods, transaction history pods, our deployment set, transaction history. We've got the 2 replicas. And what actually happens with this is there'll be a very, very short outage, not visible to the human eye, and then the other pod will take over. So actually it'll just say, oh, this pod's not reachable. I'm going to flick over to the other pod. So that's actually what occurs when you test this out with Gremlin in real time. So that's awesome. No error message is visible at all to the user. They just get the data. So yeah, you're still able to see all of your transaction history. You no longer receive any error messages. So this is a really nice way to just quickly fail over that service. Here's the URL, Google Cloud Platform /Bank of Anthos, if you want to check that out on GitHub. Now, the next key practice that I want to speak with you about is game days. So game days are a really great team building exercise. And something that Accelerate talks about in the Accelerate book, it says that game days are a great way to build relationships within an organization, and it's a cultural must-do to become a high-performing organization. I definitely agree here. They not only help you improve stability or reliability, but definitely tempo, because it enables you to work closely with other teams that you want to have better relationships with, especially if you're in a larger engineering organization. So we actually have a lot of resources. If you go to gremlin.com/gameday, there's some free resources there for how to run a game day, but I'll explain it to you today how to do it. So this is an example of a game day. What you would do is you would invite 4 people to attend or more. It's always good to have, I think, 2+ teams. So for example, when I would run these at Dropbox, I would have my team, the databases team, and I would invite another team, for example, the server file journal team. That team's responsible for making sure that there's a record every time any change happens within Dropbox to any folder, file. And if I have some type of failure, I want to know how that appears to them. And if they have some type of failure, I want to see how that impacts my database systems. So that's why game days are so good. You're doing it in real time. It's not during an incident. You're actually doing it at 10 a.m. You can do it when you've all got coffee. You're sitting together on a Zoom call, and you can just learn a lot. And you don't have to spend hours doing this. The fastest game day that I've run, we did 3 experiments in 10 minutes. This was actually recently with a Gremlin customer, a really large consulting company, one of the big names that has folks all over the world, and they built a lot of internal tooling to manage that work. So they wanted to do chaos engineering to make sure that that was always up and running and available, working as expected. So then what you do is, I generally see folks these days, they will spike load, for example, using Gatling or JMeter, and then they'll introduce different types of failure modes with Gremlin. So for example, if you use JMeter, you could be like, all right, let's send a bunch of requests, but now I'm also going to spike CPU with Gremlin because our auto scaling is maybe based on CPU, or maybe it's based on a mix of CPU and requests. So that enables you to actually create that situation where auto scaling should occur, and then you can see that it works. And then when traffic subsides, the CPU attack finishes, you can run one for 60 seconds. It will then go back to normal and you'll scale back down. So that also helps you with a lot of other things too. If you're thinking of like cost management with cloud infrastructure, keeping costs low, a lot of SREs really care about that too. Like, how can I say, like, we saved this much money. We were able to make sure that we could quickly scale down when we don't need to be up and running a large number of machines within our fleet. So 10 minutes, very fast. Here are some other example game days: dependency testing, capacity plan testing, and as I mentioned, auto scaling testing. So capacity planning is an interesting one. I've definitely seen outages where folks tried to scale up during a peak traffic day and actually just didn't have the limits set correctly, that they were even allowed to do that. They didn't have the permissions set up. So there was some caps and they just couldn't scale. So that's always a very bad situation. Definitely want to test to make sure that your caps are not in place in a bad way that impacts you. The other thing I have seen is teams have caps that are within an organization. So maybe one team runs out of their cap, but then another team, there's like a downstream effect, and then it takes out that other team and it takes out other teams. So I've seen some really unexpected outages just based on caps and configuration of cloud infrastructure. Definitely thing to check out. So the next one that I want to talk about, the next key practice, is disaster recovery. So this is our third one. So here, outages are simulated or actually created according to a pre-prepared plan, and teams work together to maintain and restore service levels. So with game days, it might be like, hey, let's test that auto scaling works. Auto scaling is not a disaster situation. That's a great situation. That means you're doing well. You've gone viral, maybe. You've got a ton of traffic. It's a big shopping day. But disaster recovery is like when things go really bad, what do we do then? So this is really where you're putting your hat on, where you're trying to think through what could be the worst thing that could happen. What if all of our databases go down? Can we fail over? What if we lose our database? Can we restore it from a backup? Those are the types of database issues that you might think of. There are so many other types of disaster modes. What happens if a region goes down with your cloud provider? Do you fail over easily? Are you multi-region? Do you have services spread across? Do you have people that have the right access if there's an issue? There's so many things to think through, but I definitely recommend putting some effort into planning out your disaster situations and then running them. A lot of the time, folks will start with tabletop scenarios or tabletop games, and I think that's a great way to do it. But what I really like about chaos engineering is you're actually injecting the disaster on purpose proactively during the middle of the day. And I've been doing this since 2009 when I worked at the National Australia Bank. We would do large scale failover every quarter to make sure that it actually worked. Like, we would test it. All of the engineering teams would go on a Saturday and a Sunday once a quarter. They'd buy us some great food. We go to a secret unmarked building. It was all very like get smart, had to go through different scans to scan your body and everything. I'm not even joking. It was real. And then we would fail over all of the services. So in case there was some type of like nuclear bomb, that was like the idea. You have to do that in Australia. It wouldn't impact your banking infrastructure if there was some type of big, large scale disaster that occurred. Or in America, it could be hurricane, earthquake. There's a lot of different types of natural disasters too. So how can disaster recovery really help you improve? And what are some case studies? So Google, they love to do disaster recovery style events. And this is a quote from Kripa Krishna, the director of cloud ops at Google. For DIRT style events to be successful, an organization first needs to accept system and process failures as a means of learning. So that's really important. This is all about learning. It's okay if things don't work. We're here to learn, and it's better to learn at 10 a.m. than it is to learn at 2 a.m. So we design tests that require engineers from several groups who might not normally work together to interact with each other. That way, should a real large-scale disaster ever strike, these people will already have strong working relationships. which means that you're able to fix issues faster. So you're actually able to resolve outages much more quickly. My personal goal to resolve an outage is actually 5 minutes. If I'm ever working on an outage, I want to be able to resolve it within that time frame. That obviously requires a lot of automation because most humans cannot work that fast. If you're doing something like, promoting a database or creating a whole new database, there's automation that you can build though to make it be completed within 5 minutes. If a human did it, it might take like 2 hours because there's a lot of work to do there. So how do you perform disaster recovery with Gremlin? We wrote up a tutorial that you can check out. If you go to gremlin.com/community, search for disaster recovery, you'll find a ton of assets and resources there. And you might be thinking, can I automate this? Sounds like a lot of work, even if I'm only doing a 10-minute game day. But yes, you can totally automate this. And I recommend codifying your chaos engineering experiments, not only because, that's great, then you won't have to manually be running them, but also because you can make them shareable. You can do version control. You can show the history of all of your chaos engineering experiments. You can save them. Specifically in Gremlin, if you add multiple attacks together, you can then add a hypothesis, and we call this a scenario. It's a specific type of feature within Gremlin. So you can use the API, or I've actually seen a lot of folks in the last year integrating chaos engineering experiments into their CI/CD pipelines. So they might do this for production readiness. They'll say, you need to pass this number of chaos engineering reliability experiments that pass through these before you can ship your new service to production or ship your change. Or maybe if they're going multi-cloud, something like that. I've seen a lot of people do that too. They want to make sure that all of the code and the services pass through these experiments, because we all know like lift and shift is not a real thing. You can't just take code from one cloud provider, drop it into another. If you've tried different types of Kubernetes offerings across cloud providers, you'll see how different they are. That's just one small example. But there's a lot of fine-grained detail to this to make sure that you get it right. But this can help automate that. And that's really nice because then you don't have to go around teaching everybody these SRE best practices. You can just build a system that enables people to quickly check. And I think through things like linters, stuff like that help us write better code, it's kind of like that idea there. You're giving people tips so that they can do better work going forward. We also recently created a state of chaos engineering report. So this was a really cool finding from it, that the top performing chaos engineering teams boast 4 nines of availability, 52 minutes of downtime a year, with an MTTR, mean time to recovery, of less than 1 hour. So that is awesome. I know a lot of folks like really aspire to get to that point, because even having an outage that goes for 1 hour, like that's pretty bad. That's definitely not my personal goal. I would want it to be 5 minutes max. But sometimes you can be working on massive outages like that Amazon S3 outage. It went for 5 hours. We got out of it early after about, I think it was 1 hour, because we managed to fix the thumbnail preview service and resolve the incident more quickly, actually. But yeah, there are a lot of interesting findings that you can get, that you can measure and say, hey, we used to have a mean time to recovery for these critical services, and it was really long. It was maybe 3 hours, 5 hours. Now we've improved it, and our mean time to recovery for this service is like 10x better, or we have 10x less incidents, something like that. It's pretty cool. So definitely check that out. And thank you so much for coming along today to hear about chaos engineering, game days, and disaster recovery. And if you've got any questions, please feel free to ask them now.
All right. Yes. Thanks. Thanks for that, Tammy. The chat, the Q&A chat is open, so you can drop questions. You can drop questions in there. If you don't know where the Q&A chat is, you can drop it in the regular chat. We'll find it, and we'll ask Tammy about it. I do have some questions. I have some questions of my own. While people are thinking. So on, so you're coming from an environment where change has always been a kind of something to be afraid of. Too many changes, you might break something. Have you been any place or worked with customers that trying to shift that mindset to be able to do a game day, during the day in a production environment. We're gonna intentionally do something that might, impact a few live transactions, but we'll learn. We could learn a lot from it. Any tips there?
Oh, yeah, definitely, Jim. So if you are interested in practicing chaos engineering in production, like I often say to folks, that's a journey, and it's good to spend, several years getting there, maybe a little bit quicker if your company's ready for it. But usually folks will start in staging, test or pre-prod before they move to production. But just recently, actually, one of our Gremlin customers is Target. So I get to hear a lot of their stories. I get to learn about what they're doing. And they've got an amazing story. Like over the last 3 years, they started doing chaos engineering specifically for disaster recovery in their pre-prod and test environments. And then just this year, to prepare for Cyber Monday, Black Friday, which is, very soon. This was a few months ago. They actually started doing chaos engineering in production, which is awesome. Wow. So that was their first time. And yeah, they did it. They got all of the buy-in. Everyone was okay. And they learned a lot from their systems. They didn't cause any huge issues, but they did learn what they needed to fix. And we all know that production is different to your staging and pre-prod environments. So if you can get there, it's better. And it's great to figure out these issues earlier rather than during a large event where you don't want to be down on Cyber Monday. Yeah.
Okay. So don't just download Gremlin and start taking out stuff from production.
No.
Start a little bit lower down in an environment where an integration environment where maybe it's simulated traffic, maybe it's a customer environment where customers can come in and still interact with it, but not your don't mess up your money making systems yet until you're really good at doing those types of things.
Yeah, definitely. And even if you want to learn just how to practice chaos engineering, you can do it in a demo environment, a development, just your own personal developer environment. I think that's also good because the thing that I've learned from chaos engineering too is often it's the failures that I see, the ones that cause the biggest issues aren't even traffic related a lot of the time or request related. They're really more like configuration problems or just bugs that you didn't find. Like I once uncovered a bug that was a data loss bug and it had been in production for 3 years. And I was part of discovering that. Yeah. So there is some scary stuff hidden under the table that you might need to find.
All right. Yeah. So yeah, don't that sounds that sounds a lot more doable in to get started in a developer type environment. Even just learning out, I guess, even on maybe if you have a whole bunch of systems strung together, even if you're just working on your own component, learning how it fails under certain conditions, can help you go back and improve your code, error message, user experience from everything that's learned there.
Yeah, that's exactly right. Like I find it's the fastest way for me to learn about a system, to understand the dependencies and understand how the code works. Because say, for example, I wanted to learn about a system called SQL Proxy at Dropbox. The person who built it, he was like this very mysterious guy that used to come in at midnight, leave at 5 a.m. No one ever saw his face. He wrote all of the code. Nobody else reviewed the code. Like it was very early on in the early days. And so, yeah, but I needed to know how that worked because it interacted with the database. So I printed out all of the code to try and understand what he'd done. You can imagine that was a lot of code. I read through it all, but I was like, I think the easiest way for me to learn how this fails and doesn't fail and all its different failure modes is going to be to inject failure on purpose. And that's what I did. I brainstormed a bunch of different chaos engineering experiments, ran through all of them, and then I was able to figure out the different modes that we should not let that proxy get into because it would cause issues. And we were able to put in some great guardrails and we never had problems with it again. So it was awesome. We didn't even have to deprecate it or do a rebuild, a rewrite, nothing like that. So pretty cool.
That's cool.
Yeah.
All right, looks like Mr. Steve Cravens posted something in the Q&A. I'll read it and then I'll read it out loud so it'll be on the recording. So how would you talk with a customer where they chaos engineering or heavily reactive versus proactive? What would be the first step you would recommend to start their journey?
Yeah. So I think it's interesting, those types of environments, maybe where there's a lot of chaos occurring and maybe people don't know what's going on or there's not much transparency. So I think like if you're in a situation like that where there's just like, maybe a lot of bugs getting pushed out the door, a lot of problems occurring, there's no really good tracking of what's going on, no measurements of it. So you're just feeling like it's more of a confusing environment to work in.
Mhm.
I think like a really good place to start is to just actually get together, create a working group. That's actually what I recommend doing for sure. It's like create an internal working group of folks who care about reliability and want to try and be more proactive and think, how can we prevent these issues from occurring? Like, what do we think works best? Because it definitely depends on the culture of your organization, and getting a few other folks to align with you, to brainstorm with you, to think through like, how can we just make a small step forward? You don't need to do a huge initiative. You can just take a small step forward. Like, how can we do our very first game day? Or how can we do our very first experiment and then show that it was worth doing it? But I personally, like, I haven't really worked in environments where it was like that chaotic that there was just like lots and lots of problems happening all the time. I think like by the time I've joined companies, they've always really cared about reliability. So I was lucky in that way. And being an SRE, they had the head count for an SRE. They wanted me to come in and make things better. So I've always joined teams like that. So yeah, but that could be like maybe a bit of a luck thing or a timing thing as well there. But I would not give up. I'd create a working group around it if people just don't understand. I have heard from friends that maybe they're working at companies where folks don't understand why site reliability engineering is important or why chaos engineering is important. And that just requires like helping educate folks on it. Yeah.
Okay. Yeah. So it sounds like a mix of possibly cultural type shift, educational, bringing the mindset of why we should care about this, because it reminds me of what you were saying about the one of the things you remembered from the Accelerate book, if I'm remembering a few minutes ago, right, that by having those environments that focus on reliability kind of frees up time to work on tempo, to work on other things, that you're not burning everybody out with fighting unreliable systems.
Exactly.
That they're able to go back and focus on virtuous type of circle. If you focus on reliability, you can then spend time creating new cool business function or something like that.
Exactly. And something that I've done in the past that worked really well. I did this at Dropbox. My team, databases team, you're going to have a ton of requests from different teams all over the organization for changes they want you to make to be able to handle like new products. Like at the time they were building Dropbox for Business, which exists now. So I was there when we created that. There was also Dropbox Paper. And I said, though, look, I don't want to roll out any new features or any new changes. I want to do a reliability sprint. And at Dropbox at the time, sprints were actually pretty long, like 6 weeks long. So that's very long for a sprint, So, but that meant that I could say, I want to do a reliability sprint. So I got buy-in from like all of the teams around me, all the teams that relied on me. They said, yes, okay, your team can focus on just improving reliability for 6 weeks straight. Just share what you improved and how you did it, so then other teams can learn from you. And that was amazing. Like, we did so much great work. We built tools for reliability. We then onboarded all of the teams across the organization to use those tools too. A lot of it was around like being able to categorize the different incidents that you have in an automated way, so you can pinpoint the problems and fix them. So like there are lots of different strategies that you can use to be able to get time to do reliability work. But like what Accelerate says is that it frees you up to do all of that awesome product work, to build new products. Like I've helped build huge like products that are being used by millions of people. So yeah, it's all good. You can have your cake and eat it too, definitely.
And if thanks for the questions, Steve. If anybody else has questions or ideas, put those in. I do have more that I'll work on. Well, maybe people think through others. So I'm just thinking of chaos engineering being just kind of like cloud, relatively a new thing in technology. So I'm guessing you didn't there was no college course on chaos engineering. So how did you find yourself in chaos engineering? I guess we'll maybe leave it open ended at that. So how did your journey end up there? And
Yeah.
that is the worst ending of a question, but
Yeah, no, that's a great question. I like the
yeah,
answer.
take it away.
Yeah, a lot of people have different roads that take them to chaos engineering. I'm wondering if
Yeah.
anyone listening, if you've practiced chaos engineering before, like share a yes in the chat too. That would be interesting to know who's actually done some chaos engineering. So for me, like how I got started doing chaos engineering, like, this really goes back to when I was at university. Like I've always wanted to build things on the internet. I've been doing that since I was 12 years old. As a 12-year-old girl in like 1996. There was not much on the internet for a 12-year-old girl back then. It was a pretty boring place, like, to be honest.
Yeah.
And I was like, I want to make things on the internet so that I can send my friend the URL and, me and my friends can go on our cool sites that we build together. And so I wanted to start doing that sort of work. And, as I was using the internet, you just would see that it would break all the time. So I'm like, it's not very reliable. Like sometimes it works, sometimes it doesn't. It's hard to figure out how to build things that work well. And then I decided, like, I want to go and study computer science at university. So I did that. While I was at university, I took some of the topics like advanced web applications, networking, security, databases, like advanced databases. So it was really like a lot of things that do prepare you to do chaos engineering, because if you have some like distributed systems knowledge, also did a lot of Linux classes. We had the Red Hat certified, exams, those ones, RHCE. So if you do those types of things, networking, security, databases, you'll then think through like, how do different failures impact my entire system? Like not just like, I want to write a feature. How do I get that out the door? Like you think through like, how does my feature fit into the whole scheme of everything that we're building, the entire architecture? Right. Yeah. And so like, from an early age, I really did care about that. Like the idea of let's figure out how this works. What is the actual architecture? Can we create a diagram before we build things? Like, how can we make this run super fast? How can we make it really reliable? Like, I cared a lot about performance and all those types of things. And then I started to work at the National Australia Bank because I thought, well, this is going to be cool. Like I'm going to work on critical systems that people care about. My mom was a customer since I was born. So I just thought it was pretty cool that I could like run the systems that my family were using day to day to like buy groceries and pay bills. And I started to work there. And one of the first projects they put me on was prepare for disaster recovery. It's in 2 months. Good luck. And I was like, whoa, okay. And it was actually an acquisition, the team that I was on. So the team had been recently acquired. It was a mortgage broking solution and nobody knew how it worked at the bank, but it made a lot of money. So we were like, well, we're helping people get into their homes. We need to make sure that this works well. And the thing with mortgages, for those of you who've bought homes, you know how important it is for your mortgage to get processed quickly. So in Australia, you want that approval to come through within definitely 24 hours, because if it doesn't, then someone else will get your dream home. So I was like, wow, we have to process this mortgage in 24 hours or like the person's not going to get their home with us. Like it's not going to happen. And usually people don't put a mortgage application into several places at once. And a few times, there were some big incidents where we didn't process mortgages. Like we weren't able to get them through. It was like taking 72 hours, a week sometimes for them to get through this huge system. Like it's quite complicated to process a mortgage. And I just wanted to figure out, how can we make it faster than 24 hours? What if you could process a mortgage in an hour? Like I just started asking questions like that. Why does it have to take so long? Like, how do we make this more reliable and make it quicker and have less different points where it could fall off and like cause an issue? And so, everyone loved those questions that I would ask. I got put on a lot of great projects over the years in different areas focusing on that. And I realized the best way to learn how a system doesn't work is to inject failure on purpose. And it's not good to wait for disaster recovery. So for those of you who have worked in very regulated industries, you go to the disaster recovery test, you have somebody look at your work. They pretty much check it off with a checklist to see if you passed or failed. And then that gets reported back to the regulatory board. If you fail, that gets reported too. And you don't want to fail twice. So what you're always trying to do between each quarterly disaster recovery test is fix everything by doing chaos engineering, by injecting failure on purpose. And actually, the National Australia Bank was the first bank in the world to use Chaos Monkey from Netflix. I'm sure many of you have heard of Chaos Monkey. And that was super cool. It was like, wow, like I was there then. It was 2011. It had just been released on GitHub. You know, we'd been doing a lot of failure injection on purpose. And then we were moving to the cloud. So we were like, yeah, we want to do more of this. And it's just been a huge journey and a big push there since then. And, you know, I always just thought, to me, this makes sense. Like, I love when you figure out that something works. Like, I also am a big fan of incident management, monitoring, automation, but chaos engineering has always been my, if I need to fix the reliability, I'm going to use that because it's like the magic wand for me. Like, and people do think, wow, that was like magic. How'd you figure all that out? It's really science, but, you know, it looks like magic.
Yeah, looks like magic. So it sounds like you started off as being even a full stack engineer before there was even that title. Through the you having Linux as a base to move from, and the application layer, databases, so that full stack before it started, and then really having to break systems to make them more reliable. It's interesting to hear that you're we're in one of the places where Chaos Monkey was outside of Netflix, where it was adopted and tried and kind of put into practice.
Yeah, and like the cool thing about working at NAB is everyone loves proactive reliability work like that. Like all of the engineers are super innovative. They were like, let's do this in production tomorrow. Like, there's like it's a vibe there. Like I've never worked anywhere else that is so much like that. But they just want to have like the most reliable systems, and they're willing to just figure out how to do it. And NAB's innovated in a lot of different ways, like not just in reliability, but all sorts of interesting, strange things. Like I remember there was this one, we had a demo bank within our office building. So downstairs, they would try out all of the coolest, newest technologies within this demo bank that you could go to. And yeah, they even had like interesting smells like that changed based on like people's like how people like them and not, and like different seasons. They would like blow scents into the air. I know it was all like really high tech. So yeah, pretty interesting.
Well, it was like a physical place with the technology, and you could go. Like a mock-up of what the banks were like?
Yep. And it was the first place to have you to be able to talk to a teller without them being behind a screen. So they were just sitting there, and the security was so good that they could just quickly hide away any money within this box that, nobody could come and steal the money, like even if there was a robber that came. So it's like really interesting technology there too. Like how can you make something feel comfortable and friendly and be reliable and secure all at the same time? Like that's not an easy ask. Back in the day, bank tellers would have to hide behind huge screens and stuff would shoot down. But yeah, they really tried to innovate there.
So that's almost like, and I guess with chaos engineering, trying to because that's like almost chaos engineering for the physical world, designing systems like that. And in the digital world, it's a little bit harder to maybe see what's going on. So the chaos engineering helps kind of expose and show what real life looks like in a problem, so you can try and fix it later.
Yeah, I definitely like that part of that's one of the big wins. And also the cool thing about game days is you realize that together as a team. You know how sometimes like one person is an expert in one part of the system, another person is an expert in another part, but then you put those folks in a room together, they can go up to a whiteboard, they can draw an architecture diagram, you can take a photo and be like, sweet, now we actually know how this system should work, and then you can figure out how it doesn't. But yeah, that's a pretty amazing outcome from it too.
Cool. Looks like we have a question from Ricardo. SREs, when implementing SLI, SLO, SLAs, have the SLI menu as a guide to start. Is there a similar concept for chaos engineering, resilience engineering?
Yeah, great question, Ricardo. So actually what I recommend doing is if you do have SLOs, SLIs, SLAs in place, then you can use those with your chaos engineering practice. So I have another talk that I wrote earlier this year on how to do that, because a lot of people said to me, hey, like I want to roll out SLOs and SLIs, but how do I make sure that they're actually accurate and correct? And then, that's the answer. Chaos engineering. Inject some failure and make sure that you see the result that you expect. Like if you expect to see, latency went over this number. Okay, like did that show up? Like did your alerts trigger that you're no longer meeting your SLO and your SLI was above what you expected it to be? Same thing for like, maybe data, connections, whatever it is. That's a really good thing to be able to do. I think most people, though, from when I've been meeting with people over the last, say, 2 years, a lot of people don't have SLOs and SLIs in place yet, or maybe they tried to roll it out and it didn't quite get buy-in. So they're still trying to figure out how to do that. And the reason it didn't get buy-in is because people didn't trust that the metrics were accurate. So that, again, like you inject the failure, you show people it going up and down, you then have proof that this does measure it correctly. And it's okay to take the time to do that. Like I think sometimes people don't trust the metrics, but if you spend a little bit of time showing them that the metrics do work, then that's going to just enable you to move forward together as a team. The other thing that I'll recommend for metrics and measuring is actually like MTTR, which Accelerate talks a lot about. And then another metric I really love is MTTD, mean time to detection. That's my personal favorite. So I wrote a book on that. It's an O'Reilly book with a few friends from Twitter, LinkedIn, and Amazon. So yeah, check that out too. If you're interested in reducing MTTD, I'll put the link in the chat.
Yeah, I'll put the link in the chat. And the talk that you were just mentioning, is there a recording available for that? We can also link that for people to take a look at later.
I actually haven't given it publicly yet. I just gave it internally, like within Gremlin for our staff.
Okay.
Yeah, but I could do it publicly soon. I'll do that and I'll add it to my YouTube, or maybe I'll just record it. But yeah, that's like I don't think many people are talking about that you could do that, right? Like you can roll out SLOs and SLIs and then confirm that they work as expected by injecting failure on purpose. And it's a really good way to do it. Yeah. And also just as you continue to run your experiments, you can showcase the results based on that. Yeah.
Cool. On the while you're searching on that, going back to one of the things you said before that you could. It's not magic; it's science. Because the idea is, running some experiments. It's called chaos engineering because you might cause some chaos by doing the experiment, but you're intentionally injecting a failure in a known place, and of the experiments that are kind of available in Gremlin today, is there any? And looking to the future, are there any that you see that are missing? I don't want to hear any secrets from the roadmap or anything, or any roadmap promises. But are there any experiments that you wish you could do that Gremlin's not able to facilitate quite yet?
Yeah, I definitely have my favorite types of attacks. So we have, 3 different categories of attacks: resource, state, and network attacks. And the ones that I found to be most useful for me, and then also for customers, I personally have got a lot of use out of Process Killer, because I've done a lot of work with database reliability. So you want to be able to just easily kill MySQL D, but then maybe also do other types of failure at the same time. So inject other types of attacks. Like let's also spike disk and spike IO, see what happens then. And then does everything cleanly come back and be replaced? But then the other things that are very popular, black hole, which I demoed, making something unavailable, and then also latency. So those 3 are my favorite. And I've seen, they all have different use cases, but I think those are 3 really cool ones. In terms of what's missing, we are definitely working on some new attacks that are coming out, in the not too distant future. I think one of the ones that I actually saw happen a lot in my time of leading engineers and having them commit code and, just maybe doing something wrong or causing an issue was something that resembles what you would think is a fork bomb, just processes going out of control, and then it eats up all of your resources, and then you have to roll that back or stop that. So yeah, I think that's a really good type of attack. Like you would think like, does this really happen in the real world? But yeah, I mean, I've seen it. So that's definitely one. The other thing that I think is cool, we did build this at Dropbox, but this is one that is it's a very specific type of failure mode, and it's a corrupted block. So say if you are somewhere like Dropbox and you store data and you have like, block data, then we actually created a corrupted block, and then we built a system to detect corrupted blocks. And that's the only way to prove it, right? Does the system work? Well, we need to create a corrupted block to catch the corrupted block to prove that it works to everyone. And that's what we did in our staging environment. And then we rolled that system out into production because everyone felt good about it, that it would work if there was a corrupted block. Yeah.
All right, cool. So we've don't have any more questions in the chat. I could definitely keep asking questions like forever. Not forever, but
it's a pretty fun topic.
Yeah, so, it's definitely a fun topic. Lots of stuff to learn, and it's great that the tooling is out there, so you don't have to invent the tools on your own. They're available, and the tools work, so you don't have to chaos engineer your tools before doing chaos engineering. They're already there. Gremlin sounds like they have a free version that we can try out on demo applications or on our own. Sounds like there's new certifications available. For those most technical people that you want to grab a certification. I'm a certification junkie, so I might put on my list to get one. But definitely appreciate you taking the time, Tammy, to come talk to us about your experience, about chaos engineering, game days, and disaster recovery. And yeah, just a silent round of applause because everybody's on mute. But thank you.
Thank you so much for having me, Jim. Yeah.